Yeah, so good morning. I'm Florent Violain from eOdyn. So we are a new, fresh company working on, as she was saying, operational oceanology, sorry. And what we do is we measure mainly ocean currents. And ocean currents today are used in many areas, like predicting, analyzing climate change, like routing vessels, situation awareness for defense, for security, maritime security. If it's about combating oil spill, if it's about like saving lives as well at sea. Well, ocean currents are used for so many applications. And today, well, there are different ways of measuring them. And main way is probably drifters, buoys drifting along. You got like about 3,000 drifters, but you never know when and where they're going to end up. The other way is like developing and deploying large infrastructure, radars onshore, but it's very good, but it's only onshore and it's quite expensive. Satellites as well. You've got only 6 satellites able to measure altimetry satellite measuring ocean currents worldwide. So, well, all of this, it's expensive, it's complex, it doesn't work everywhere, it doesn't work all the time. And so what we've been thinking about within eOdyn is, well, there are ships everywhere on the oceans. There are more than 100,000 ships every day, every night, like cruising all the oceans. So you see like a density map of ships. So everywhere where there is human activity, there are ships. So what we do is we analyze human activity to be able to understand nature. And we calibrate with machine learning algorithm and lots of different subjects about hydrodynamic and yeah. And what we do is we calibrate each of these vessels into a sensor working for us to be able to measure where the currents, where it's going through. And so you see in this video where ships are becoming vectors, so we can identify the velocity, direction of ocean currents in real time and in the past as well, up to 10 years back. Because our main feeding information is AIS position, which is basically any commercial ship on the world has a beacon which is giving every few seconds its position and its name. And we take this information, we process it, and we make ocean observation. So we take a communication system into an observation system. And that's very new, that's very innovative, and it works very well. Yep, sorry. And interesting thing with this, we sail 100,000 ships everywhere, all the time. So we can virtually monitor everywhere at the same time, all the oceans. So we've got like virtually global coverage, no limitation offshore. Very interesting resolution. We are looking at, so if you look at the world ocean with a square of 5 per 5 kilometers, for example, and as I was mentioning, we can collect this information real time and also in the past. So you've got like debris of MH370 plane, like going onshore. You can track back its trajectory and cross with the trajectory of the plane, sorry, and you might be able to find the plane. It's no deployment at all because all the installation infrastructure is already existing and we just use it a different way. Yeah, the way we do that, so we collect information from satellite, from coastal base, from vessels as well. We process it with some algorithm, machine learning algorithm, hydrodynamic algorithm, and then we make it looking good with filtering, with visualization, and we provide services out of this, which are like we are mentioning situation awareness services that we are discussing with Thales. Being able to provide services for offshore drilling station, for platforms, production platforms offshore, for shipping as well, like saving fuel on shipping. If you look at major companies spending $5 to $10 billion per year in fuel, if we can save 2 to 3% by routing properly with actual situation, well, that's still big savings. And next step is today what we are doing with for offshore exploration in South Africa for an oil and gas company. We take our surface current information in real time and we translate this into current from the surface to seabed, because that's for drilling operation where you need to understand what's happening underneath. And next step as well is today we work with currents, but to be able to measure currents, we have to understand what are the implications with wave and wind. So tomorrow we should be able to get wind, wave, and current at the same time for any vessel on the world. So it will be quite amazing, to be honest. And so we work with already different major names and different type of project within shipping industry, oil and gas industry, airspace industry, and defense as well. So thank you very much.